Okay, I'm testing this BiTT transformer. Hector likes to call them hemorrhoidal transformers. But basically, here's the high impedance input I have that's taking in 120 volts AC. Goes in here. These are in series, the two secondaries. That's the output. I put the output across a 50 ohm resistor. And across a 50 ohm resistor, 16.3 volts. So if you want to figure out the watts output, it's 16.3 times 16.3. You square it, divided by 50. So that's what the watts is. Output. The input is going to be the volts times the amps times the power factor. If you have 90-degree power factor, that means you have zero power. That's zero. And so you can have like 1,000,000 volts times 1,000,000 amps, but if it's 90 degrees phase shift and it's zero power factor, it's 0 watts being consumed. So isn't that nice? So what you do, I'm sorry, the scope is flashing. It looks good with my eyes, but when I use my camera, it only picks up these flashes. So let's see if I can see the... I have looking with my eyes, it's a little bit over 2 spaces. 2 spaces, the little between there. That's the phase shift, is 2 of those small square spaces. And now I'm going to look and see, I'm going to, the start of a sine wave, and then where does it end? Looks like it's 8 spaces. And so what I'm doing there is you look where the sine wave starts on the 0 line, goes up, comes down, comes back, and then it goes there. So what's the spaces in between there to there? That's 360 degrees. That's an entire AC cycle. It's 360 degrees. So let's say it's 8 spaces. Let me take this out right now. It gets hot. Okay, so 360 divided by 8 equals 45 degrees per one of these little spaces here. And I just saw a little bit over 2 spaces for the phase shift. And 45 degrees times 2 is equal to the magic number of 90. 90-degree phase shift means your power factor is 0. You can look it up if you don't believe me. So, with a 50 ohm resistor, which has got kind of hot, but it's unplugged now, there's essentially 0 input, although if you measure the current circulating coming in, it's 230 milliamps if you do it with a meter, and it's 120 volts. So the undoctrinated might say, oh, well, it's like 23, 24 volts. I mean watts, around there. And but it's not. It's 120 volts times 230 milliamps reactive power, VARs, reactive, because it's not in phase. It's 90 degrees out of phase. So we have 0 for the input. Isn't that nice? So let's look at this. I made these shunt bars out of just steel I got at Home Depot. There's a little feature I do in my design is I catch the flux coming out the sides back here. And so what happens, how this works is you send in power here and current flows through here and current flows through here, and it makes power in the secondary. It's a transformer. It's transformed power into here. This happens to be a step-down transformer. I have 15 volts on the output with both of these in series and 120 volts on the input. So the output then is these two in series, and here's that resistive load to find out what the watts is for the output. And the input is these two white wires, and you run, well, one channel's picking up the volts over here, and you have the tip of the scope probe right on one of the AC lines going into the primary, and the other AC line, which is this white wire, it goes in series through a 1 ohm resistor, and the other side of the resistor goes to the other AC line down here. So this is how you hook up the scope. And now you take the scope probe, which is the current one over here on A, and you put the tip of it probe goes to one side of that resistor, and that little ground clip black thing goes over here on the other side of this 1 ohm resistor. So this tells you what the current is via what the voltage is here with a 1 ohm resistor in series. And you can trick yourself by making it backwards, but if I switch these around like this, put the red over here, black over here, it's showing the same thing. So I'm not running it backwards or anything. And actually that's how it should be when it's 90 degrees. So anyways, so I tested this out. Now how to take advantage of this is another thing. I mean, we need a power factor friendly inverter or something. One thing you can do is you can get an old house meter, one of those glass globe house meters, and use that as the measure the power input, and since it's 90 degrees phase shift, it should make the spinning disc inside of those just stop. And that's one thing you can do. And to prove there's no power input. But where everybody goes wrong, or maybe right, is they measure the amps in and the volts in, and then they say, oh, this is the watts, but they don't include the power factor. And in power factor is only something in AC that you can mess with. So it's the AC watts out input is volts times amps times PF, power factor. And if it's 90 degrees, the power factor is 0. So volts times amps times 0 is equal to 0. Isn't that nice? Okay, well, this seems to be working. pretty good. And I'd call this a converter, a reactive converter. It converts reactive power to real power. And it's also a transformer, a step-down transformer. So that's about it. Okay, thanks for watching.